Hello everyone, my name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, and sometimes about software engineering in general. If you have been liking the kinds of videos that I make, maybe you should consider subscribing to my channel and you can follow me on Twitter and we can discuss about some of these things there as well. In this particular video, we are going to talk about how we can authorize a particular user to do certain things on Kubernetes cluster. So once we have a user that is already authenticated, all the accesses, all the things that he is allowed to do can be configured using authorization mechanism. And one of the authorization mechanisms that Kubernetes supports is RBAC, role based access control. So when we talk about authorization, we are actually already assuming that the user is already authenticated and using any authentication mechanism. So for example, let's say we have this Kubernetes cluster and we have another user that wants to talk to this Kubernetes cluster. And if this user wants to talk to this Kubernetes cluster, obvious that this user needs to be authenticated before it can talk to the API server. Now, after the user is authenticated, there is another step that is authorization. And in this particular video, we are going to focus into this particular thing, that is authorizing a particular user to do certain things. Now, if we talk about the user that wants to talk to the Kubernetes cluster, as we have already discussed in one of our previous videos, this user can either be an actual person or this can be a program that wants to talk to Kubernetes API server. And in case of program, we are going to use service account to authenticate or authorize this program against Kubernetes API server. So yeah, if I try to summarize this once again, in this particular video, we are going to focus into authorization aspect uh, of Kubernetes, and we are assuming that the user that we are going to authorize is already authenticated using any authentication mechanism that Kubernetes supports. For example, either using token bearer or using client certificate or using basic HTTP auth username and password. So if we want to figure out the RBAC mechanism or authorization mechanism that Kubernetes cluster is using, we can go ahead and try to look into the definition of Kubernetes or Kube API server pod, and there we would be able to figure out which particular authorization mechanism is being used. So if I already have a one node Kubernetes cluster set up, and if I try to look into the details of Kube API server from Kube system namespace, we can just go ahead and try to describe the things, but I prefer edit instead of describe, because when we use edit, we get this nice VI editor and we can quickly move around this file. So here we can see the authorization mode that is set up for Kube API server is node and RBAC. It simply means that RBAC authorization mechanism is supported on this particular Kubernetes cluster. Now, to support this authorization that we just discussed about, Kubernetes provides four basic objects or resources, and all these resources are from this API group named rbac.authorization.k8s.io, and these resources are RoleBinding, ClusterRole, and ClusterRoleBinding. Now don't mind the typos, please. So using these four Kubernetes resources, we are going to configure a specific user to do certain things on Kubernetes cluster. So in this particular video, we are going to look into a user that is service account, but as I said, these things are going to work similarly for any other user, like any other human being. But in this particular video we are going to look into how we can authorize a service account to do certain things, and the exact same thing can be applied with any other user. So again, in previous videos we have looked into service account, and we know that in any namespace a service account gets created, and there is this nice little utility that kubectl client provides to check certain access against Kubernetes cluster. So for example, let's say if we want to check if this particular service account is allowed to do certain things, we can use kubectl auth, and then can I, let's say if you want to check if this particular service account is allowed to delete pod from namespace, let's say kube system, we can say as. And to specify a service account as user, what we can do is we can say system colon service account colon namespace and name of the service account. So here we can clearly see that this particular service account is not allowed to delete pods from kube system namespace. If I try to explain this command once more, using this particular command kubectl auth can I, we can figure out if a particular user is allowed to do certain things or not. And using this specific command that we have written here, we are trying to figure out if this particular service account, or if we try to relate with this particular diagram, we are trying to check if this particular service account named, let's say, default in default namespace is allowed to delete pods from kube system namespace. And that is what we are trying to figure out using this particular command. And the answer is no. So now we are going to make changes using these resources that we discussed about to allow this service account or this user to delete pods from a specific namespace. And if we talk about these use cases, there are certain use cases that we can talk about. For example, let's say we want this user, this service account, to be able to delete pod from a specific namespace, or we want this user or this service account to be able to delete pod from multiple namespaces, or the third scenario would be we want this service account to be able to delete pods from every namespace, or we want this service account or this user to be able to delete, let's say, some other resources that are not namespace scoped. So as we can see here, if we talk about these two resources are basically used in case where we want to deal with namespace scoped resources, but these objects are used in the cases where, or in other words, I would say these objects are mostly used in the cases where we want to deal with cluster scoped resources. For example, storage classes, nodes, persistent volumes, and things like that. So now let's just go ahead and try to look into the first scenario, that is we want this service account from default namespace to able to delete pod from a specific namespace, that is kube system. Or let's just go ahead and try to create a new namespace named RBAC -test1, and we want this service account from default namespace to be able to delete pods from this namespace. And if I run the auth command again to check if default service account can delete pods from our backtest namespace, we can see that we are not allowed to do that. Now to enable default service account to delete pod from our backtest1 namespace, what we can do is we can see here we are dealing with namespace scoped resources. Pod is a namespace scoped resource, so we are going to create role and respective role binding. So kubectl create role we can use this way to create role. We can go ahead and try to create manual manifests manually as well, but this is easier, and we are going to look into manifest as well. So kubectl create role, let's say the name of the role is delete pod, and we want to create it in the namespace RBAC test1, and we want to allow verb delete, and we can allow other verbs as well. For example, if you want to allow listing and updation of the pods as well, we can also specify list, update, and things like that. But in this particular scenario, we are just interested with deleting the pods. That is the reason we are going to choose verb as delete, and we want to deal with resources pod. So now we have just created a role that allows someone to delete pod from our back test1 namespace. Now we should somehow associate this particular role with this particular service account, and that is where role binding comes into picture, to associate a particular user with a particular role. So kubectl create role binding, and let's name it delete pod role binding -n RBAC test1, and we are going to provide role as well as service account. So the role that we are going to specify is delete pod, and service account that we want to associate is default service account from default namespace. So default namespace and default service account. If I hit enter here, we can see that this role binding has been created. And if I check again, if this particular service account from default namespace can delete pods from our back test1 namespace, we should be able to see yes. So we have just, using role and role binding resources, we have just allowed default service account from default namespace to be able to delete pods from this namespace. Now let's just go ahead and try to look into another use case. Another use case would be, for example, let's say we want to allow the same service account default from default namespace to be able to delete pods from multiple namespaces. So for example, I want this default service account to be able to delete pods from kube system namespace as well. If I just go ahead and enter kube system here, we should be able to see no, because this particular service account is just allowed to delete pods from our back test1 namespace. Now to do this, what we can do is we can just go ahead and try to create the exact same thing that we did for our back-test1 namespace. So we can go ahead and try to create another role in the kube system namespace. So let's just go ahead and try to do that. So kubectl create role named delete pod in kube system namespace, and this is for verb delete and resource pod, and again we will have to create role binding to associate this particular role to the default service account. So kubectl create role binding, name of this role binding is delete pod role binding, and it should be created in kube system namespace. It associates the role named delete pod with service account default from default namespace named default. And if I just run this command again, we should be able to see yes, because we have just specified role and role binding. Now there is this another use case that I would like to talk about. For example, let's say there are n number of namespaces, and we want to allow this service account to delete pod from all those n number of namespaces. So let's say n is either 5, 7 or 10. So we want this service account to be able to delete pod from all those namespaces. And in this specific scenario, let's say we want this particular service account to be able to delete pod from RBAC test1, cube system, and there is another namespace, let's say local path storage. And if we check if this particular service account is able to delete pods from local path storage, we are able to see that it is not able to. In this particular scenario, there are two ways. Either we can go ahead and try to create role and role binding in all the namespaces. For example, we have already created for cube system and RBAC test1 namespace. But if there are a lot of namespaces where we want to allow the exact same thing, exact same role, in that case, we will have to either create role and role binding in all the namespaces, or there is another way that we can use, and that way is creating cluster role and binding that cluster role to a user using role binding. So let me maybe write that down to make things clear. So this use case is the third use case I think that we are talking about, and we want to allow user to do certain things in n namespaces. So one way is to create role and role binding for this particular rule in these n namespaces, or we can create cluster role and that cluster role can be bound to n namespaces using role binding. So let's just go ahead and try to do that. So what we can do is we can delete the role bindings and roles that we have already created. So kubectl delete role from RBAC test1 namespace, name delete pod, and delete role binding from RBAC test1, and it should be named delete pod RB. Similarly, we are going to do the same thing that in the cube system namespace. So delete role from cube system namespace named delete pod, and delete role binding from cube system namespace named delete pod role binding. And now if I run this command once again for RBAC-test1 namespace, we should again get no, because we have deleted roles and role bindings. Now let's go ahead and try to create a cluster role like we discussed over here. So kubectl create cluster role, and let's name it allow delete pod cluster role. And this, since cluster roles are cluster scoped resources, we don't have to specify namespace. We can just specify verb, that is delete, and resources that are pods. And let's just go ahead and try to generate YAML. So cluster role or allow delete pod cluster role .yaml, and we will also have to associate this particular cluster role with the role using role binding, and that role binding is going to be created in the namespaces where we want to allow the access. For example, our use cases was that we want to allow this service account to be able to delete pods from cube system, local path storage, and RBAC test. So we will have to create role bindings in these three namespaces, and after that this service account is going to be able to delete pods from these three namespaces. So kubectl create role binding, and this role binding is going to be created in cube system namespace, or let's first look into RBAC test1 namespace, and this is going to refer a cluster role named, and it is going to associate this particular cluster role with service account from default namespace named default. And we want to look into the manifest first before creating So let's name it allow delete pod role binding. Here we go. Now, if we just go ahead and try to look into ClusterRole, we can see here this is from RBAC.authorization.k8s.io group from version API version v1, and it has specified some rules, and those rules are access of delete verb on resources pods, and since resource pods are from API group core, we are not specifying anything here. But if we wanted to do something with deployments or any other resource, we will have to specify respective API groups here. And let's just go ahead and try to create these things. So create -f allow delete pod cr.yaml. So we can see that ClusterRole has been created, and if we go ahead and try to create role binding, this role binding is going to be created in RBAC test1 namespace. And if I hit enter once again, we can see that we are clearly able to delete pods from RBAC-test1 namespace. Now if I do the same thing for cube system namespace, we should not be able to do that, and to allow that we will have to create role binding in the cube system namespace. So using this particular mechanism, creating cluster role and binding that using role binding, we are removing overhead of creating role in every namespace. So because we have created a cluster role, we are not creating role resource in every namespace, and that is what we are able to do when we associate cluster role with role binding. And if I go ahead and try to create role binding in cube system namespace for cluster role and service account default and default, allow delete pod in cube system namespace, let's say, and if I hit enter once again, as you can see, we are able to, it simply says that we would be able to delete pods from cube system namespace after creating this role binding. So the other use case that I wanted to discuss about is, for example, let's say even if we are talking about namespace scoped resources, but we want this service account to do certain things in all the namespaces. For example, this particular service account should be able to delete pods from all the namespaces that are there on the system. So if we say all the namespaces, there are other namespaces as well. And if I try to check the same thing for, let's say, local -path storage, we should get no. And similarly for cube-node lease. So yeah, I mean, it simply means that default service account is still not able to delete pods from all the namespaces, and this is where we can leverage cluster roles and cluster role bindings. So let's just go ahead and try to achieve that. So I'm going to delete these two and create cluster role, and we will not have to specify namespace because cluster roles are cluster scoped resources. Verb delete and resources pod, allow delete pod cluster role, and we want to, if we want to, we can look at the YAML as well, but let's just go ahead and try to create the cluster role. And now we can create the cluster role binding to associate this particular cluster role with this service account. So create cluster role binding for cluster role this and service account from default namespace named default, and let's name it cluster role binding. And now this service account should be able to delete pods from every namespace, and we can just go ahead and try to check that as well. Here we go. It is able to delete pods from this namespace. It should be able to delete pod from the other namespace as well, for example local path, storage, and things like that. Now we are actually, I think we are actually pretty confident about how to allow access to namespace scoped resources. Let's just go ahead and try to look into how we can allow access for cluster scoped resources. For example, let's say nodes. So if I check if using default service account, I can list nodes, and as we can see here, we are not able to list nodes using default service account. And since we know nodes are cluster scoped resources, we will have to create cluster role and cluster role binding. If you want to figure out if a particular resource is cluster scoped or namespace scoped, you can do API resources, kubectl API resources, and it is going to get us all the API resources that are registered, and it is going to tell us if that particular resource is namespaced or not. And if I grab node here, we can see that nodes are not namespaced. It simply means that nodes are cluster scoped resources. So to allow that, let's create ClusterRole verb list and resources node, and allow list node. And to bind this particular ClusterRole with this service account, we will have to use ClusterRole binding resource. So create ClusterRole binding for ClusterRole this, and with service account from default namespace named default. And now we should be able to get yes. So yeah, I mean, if I try to summarize the things once again, these are four Kubernetes objects using which we can allow access to a specific resource to a particular user, and user can either be an actual user or a service account. For cluster scoped resources, we should use cluster roles and cluster role bindings, but there are certain scenarios in which we would want to use cluster role even for namespace scoped resources, and this is the case where we did that. So for example, if we want to allow a user to do certain things with a namespace scoped resource in n number of namespaces, in that case we can use cluster role and bind that to role binding in respective namespaces. Or if we want to allow a user to do certain things with a namespace scoped resource in all the namespaces, in that case we can create cluster role and bind that to cluster role binding. So yeah, this is about these four resources that I wanted to talk about. The other thing that I wanted to talk about is aggregated cluster roles. So for example, let's say if you want to create a cluster role out of n number of other cluster roles, so what you can do is you can create a cluster role, as you can see here, cluster role with aggregated rule, and aggregated rule is going to specify label that is going to be looked for. And if any cluster role is going to have this label, this particular cluster role would be updated. Rules for this particular cluster role would be updated by the rules that those cluster role have. So for example, if I just go ahead and try to create a cluster role, let's just go ahead and try to create this just to show you how things work. So create -f aggregated cr.yaml, and if I get cluster role named aggregated named monitoring, name of the cluster role is monitoring, we can see that in rules we don't have anything as of now. And if I just go ahead and try to create a cluster role that has this label, the rule that we specify in the new cluster role is going to be added in this particular cluster role. So let us go ahead and try to do that. So So you can say here for roles we don't have anything, but this cluster role has aggregation rule that looks for any cluster rules with this particular label, and if there are any cluster rules with this particular label, those rules will be added in this particular cluster role. So let's just go ahead and try to create a cluster role. So create cluster role named monitoring endpoints and allows verbs list and watch on, let's say, resources services. And since we want to add the label, let's just go ahead and try to generate the YAML. And once we have YAML, what we can do is we can add the label. So metadata and labels, and the label that aggregated CI is looking for is this. So what we are going to do now is we are going to create a cluster role, and this cluster role is going to have the same labels that this aggregated cluster role is looking for. So if I create this, as you can see here, the rules have been added in the aggregated cluster role. So yeah, this is what I wanted to talk about aggregated cluster role. So we can specify aggregation rule. In aggregation rule, we can specify labels for cluster role, and if there are any new or existing cluster rules with the same labels, rules from those cluster would be added to this aggregated cluster role. The other thing that I wanted to talk about is if we look into any specific cluster role, we can for example, let's say if we talk about this particular cluster role, we can see that the rules here is a list. So this particular character specifies list or array, so we can specify multiple rules in single cluster role or role. So we can go ahead and try to do something like that. So API groups from, let's say, apps, or if we want to specify group to be core, we can leave this empty, and resources to be, let's say, pods, and we can specify verbs as well. So for example, list, update, and things like that. So what I wanted to say is even in a single cluster role or role, you can specify multiple rules like we just did here. The other thing that I wanted to talk about is, for example, there are some things that are not resources in case of Kubernetes. So for example, pods, services, deployments, endpoints, all these things are resources, but there are some things that are not resources. So for example, let's say those things are just endpoints. They are not resources. So if we talk about how do we get logs for a specific resource or specific pod, in that case we call logs endpoint for that specific pod. So if I say so what I wanted to show here is here we go. So this is what I wanted to talk about. So in this particular case, we are going to call /log endpoint, and /log is not a resource. So in that case, if we want to allow access to the things that are not resources, we can also do that, and we call them let me see, non-resource URLs, because we know that logs are not resources, but we can either allow access to these resources or some other, sorry, not resources, endpoints I would say, because logs are not resources, and we can do that using something like, for example, let's say pod slash log. So yeah, this is another thing that I wanted to talk about. So we can allow access to non-resource endpoints as well. We can you can, if you want to look into the details of it, maybe you can refer to the docs, but it's pretty simple. Everything is exactly same. We just specify different resource. For example, as I said here, pods slash log. The other thing that I wanted to talk about is some Kubernetes creates some, by default creates some system cluster roles and role bindings. So if you want to figure that out, if you want to explore that, you can look into that as well. For example, it creates cluster roles, default cluster roles, and bindings for core components, for example API server, scheduler, and it creates cluster roles for default controllers as well. So if you see here, we see all these cluster rules, and as we can see, this particular is for deployment controller, and as I said, deployment controller is default, or Kubernetes core controller. So Kubernetes by default creates cluster rule for these controllers and things like that. And as we can see, all these default cluster rules are prefixed by system colon. So this is another thing that is important, I would say. If we create cluster rules, maybe we should not prefix them with system colon, because Kubernetes system cluster rules are prefixed with them. So yeah, this was, I think this was pretty much it, what that I wanted to talk about. And as I said, if you liked the video, maybe you should consider subscribing to the channel, follow me on Twitter, and yeah, this was pretty much it. I will see you in the next one. Thank you.